So next one is a Franklin oscillator. So this is also based on LC circuit, tuned circuit. So they don't come under conventional LC oscillators, but they are special type of LC oscillators which use LC strictly in their collector side. So in the previous examples, we have seen the tank circuit in the feedback component, but here these oscillators, Franklin oscillator, they are going to use the tuned circuit in the collector side of your amplifier. So it is going to use a two-stage common emitter amplifier. So naturally, this will provide a phase shift of 180. This is going to provide a phase shift of 180. The total phase shift is 360. So the feedback path will not have any phase shift. Either you can use this resistor for feedback, or you can just connect this circuit without any resistor also. So already my condition is satisfied here. The total phase shift to 360 is satisfied already in the forward path. So in the feedback path, I don't require additional phase shift. So I am using a resistance. You know, in a resistance, voltage and current are in phase. So the phase shift is going to be 0. So either you can use RF or you can use RF equal to 0. You can short circuit the output and input. And you can see I am having a tank circuit in the collector of Q1. So L parallel to C, and practical inductor will always have a resistance. So you have RS, LS parallel to C. And I'm going to use voltage divider biasing for both the transistor for stabilizing the Q point. And output of Q1 is connected to the input of Q2. So since it is a common emitter amplifier, output of Q1 is taken from collector. It is given to input of Q2, which is going to be your base. And again, output is measured across the collector of Q2. The feedback path is also taken from the collector of Q2. So this is going to be the circuit diagram of Franklin oscillators. We always ensure that the loop gain mod A beta is slightly greater than 1 for sustained oscillations. So the frequency of oscillation will be 1 by 2 pi into square root of LC. So it is going to be 1 by 2 pi into square root of LC. So this is about Franklin oscillator.